Hey there, this is Mr. Weaver, and this is Topic 1, Lesson 6, on the distributive property and also determining the number of solutions. After this lesson, you need to be able to solve equations with variables on both sides and those that involve the distributive property. And you need to be able to use the structure, so what the equation looks like, to determine how many solutions it will have. You'll know you're successful after this lesson if you can solve equations involving the distributive property and determine how many solutions an equation has. So first, what is the distributive property? The distributive property allows us to multiply each term inside the parentheses by the number outside the parentheses. And algebraically, we would say A times the quantity of B plus C would be A times B plus A times C. And then one caution, be careful with your sign, especially when multiplying with positives and negatives. First, write down as many words or meanings as you can of 3 parentheses 12. Pause the video and write down what you can. Right. Hopefully you had a chance to write some stuff down. I came up with 3 times 12, 3 multiplied by 12, the product of 3 and 12, 3 groups of 12, and then a real situation. You ordered 3 meals at a restaurant and they cost $12 each. All right, next part. Using our same thinking from the part we just did, what would the meaning behind 3 parentheses x minus 4 be? Pause the video and write down as many things as you can think of. All right, hopefully you had a chance to write some stuff down. So using my same order as I had before, now I'm going to say 3 times x minus 4, or 3 groups of x minus 4. Or you ordered 3 meals at a restaurant and they usually cost X dollars, but they were on sale for $4 off. Now, we're going to focus on the second one, 3 groups of x minus 4. So, third part to this, I want you to use a pictorial model, so a hanger diagram, like we did in previous lessons, and sketch what does 3 times a quantity x minus 4 look like. Then, write a simplified expression. Pause the video and write down what you think it should look like. All right, now that you've had a chance to write it down, let's look at what we should have had. So I'm going to focus, like I said, on 3 groups of x minus 4. So if I have my hanger diagram, I had x minus 4. There's one group, but I need 3 groups. So there's a second, there's a third. So if I had 3 groups of x minus 4. If we want to simplify that, now we can group all of our x's together and then group our constants together. And we say there are 3 x's and then the negative 4's would make negative 12. That would be our simplified expression. We're not going to put anything else on the opposite side of the hanger diagram quite yet because it's not an equation and we can't solve. Last part to this. In the same context as before, what could 3 times x minus 4 equals 24 mean? If you came up with a real situation on your own, use that one, or I came up with a restaurant example. Maybe go with that one if you need to. Pause the video and write down what you think. All right, here's what I came up with for our quantity. 3 times x minus 4 equals 24. So you ordered 3 meals at a restaurant, and they usually cost X dollars each, but they were on sale for $4 off. So that was our part from before. Now, your total was $24. It equals 24. There is our full equation. If we wanted to come up with a pictorial model for this, again, 3 groups of x minus 4, but now it equals 24. So 3 groups of x minus 4, and it equals 24. If we wanted to go about solving it, we could use our process for hanger diagrams and figure out what value of x makes this hanger stay balanced. Next, let's look at some proofs like we did in lesson 4, but this time using our distributive property. So the process is still going to be the same as it was before. We're going to do what we need to do to solve and then justify using a property of equality. I'm going to start with the distributive property. Now, it doesn't look like there's a number out front, but there is a negative sign. That is showing that it's -1. So I need to multiply everything in that group by -1. If I do that, I'm going to do -1 times 2x, and I'm going to do -1 times 5. Bring down the rest so that plus 14 equals 22. So what I end up with is -2x minus 5 plus 14 equals 22. What did I do to get there? I used the distributive property. Continuing on, I'm going to combine like terms. -5 plus 14 is +9. So I'm going to write that I combined like terms. Now, to get rid of that +9, I'm going to remove or subtract 9 from both sides. So I'm left with -2x equals 13. And to do that, used the subtraction property of equality. And then finally, I would have to divide by -2 to get my answer. And I use the division property to do so. So really, everything in here we've already covered. We're just having one more step of that distributive property, and that's usually at the beginning. Let's look at another example, but instead of distributing, what if we decided to divide by that number out front? Because remember, distributing is just that multiplication. If I'm going to choose to divide instead of distribute, then what I need to do is get that distributive part, so this whole first term here that's showing my distributive alone on one side. So to do that, I have to do the opposite of -20 to both sides, so I'm going to add 20. Now I have the distributive part equal to 40, and I did the addition property of equality to get there. So this time, instead of distributing, I'm going to divide. So that's showing multiplication, so I'm going to divide by 4. I end up with what was inside, 8x plus 4, and then 40 divided by 4 is 10. Now I can go through solving how I've been doing before. So subtract 4 from both sides, 8x equals 6, using subtraction property, and divide by 8 using our division property, and I would end up with x equals 0.75 or 3/4. Some instances it might be easier to distribute and solve, and some instances it might be easier to divide. Okay, you have options. Both work. You just have to know the process to do it, and you might have to test out and see which one works easier for you. The next part to this, we're going to look at the number of solutions that could happen when we are solving equations. Now, what you've been used to is your teachers, or in previous grades, you've been told solve this equation, and you go through and you get x equals some number. Okay, now that doesn't always happen, so we're going to look at those instances. As we're going through this, we're going to look at the types of solutions, and we're going to focus on the structure to decide how many solutions it has. So structure is like, what does it look like? So our first type of solution, we could have one solution. This is so only one value of the equation is true. This is the type that you are used to. You come up with your answer of like x equals 9 or x equals -3. There's one answer that makes everything true. So what does this look like? It's going to look like there are different coefficients of the variable on opposite sides of the equation. If I look at this example, 3x plus 5 equals 5x plus 3, I can see that it has different coefficients in front of x. So 3x is on one side, 5x is on the other. The rest of it doesn't matter. As soon as I see that they are different, I know that there's going to be one solution and that I can solve for x. The next type of solution is no solution. This means there is not any value that we can find that makes the equation true. So what does this look like? It has the same coefficients of the variable, but different constants. So if we use the same type of format, 3x plus 5 equals 3x plus 9, it had the same coefficients of 3 on both sides, but the constants are different. So plus 5 and plus 9. The third type of solution is called infinite solutions. This means that any real number is going to make the equation true. And you might also see it as all real numbers. What this looks like, it's essentially the exact same on both sides. So if you ever get to a point and you have the exact same thing on both sides, the same variable, coefficients, constants, everything is the same, it's infinite. So this has the same coefficients and it has the same constants. No matter what we plug in, it's going to be true. So let's look at some more examples with our distributive property and using the structure to help figure out if we need to continue solving or if we can know right away if there's no solution or infinite solution. So given what this looks like, I cannot tell right away how many solutions there are. So what I'm going to do is work to simplify it until I can know for sure. So if I distribute half of b, so 0.5b minus 5, so half of b and half of 10 equals the rest. And I use the distributive property to get there. Now that I'm in this format, I can tell right away by looking at my b's, they have different coefficients, so I can solve this. There's one solution. 0.5 is not the same as -2. So I'm going to continue going through and solving. So I could add 5 to both sides to get rid of it on the left. I use the addition property to do so. I could add 2b to get rid of the 2b on the right. Again, I use the addition property to do so. Finally, I can divide and find that b equals 12. So I was right. Looking at the coefficients, I was able to solve. B was equal to 12. There was one solution. Let's look at this next example. So now I have distributive property on both sides. I'm going to distribute out. First, I'm going to distribute on the left. So -5 times k and -5 times -14. Then I'm going to distribute on the right. That -1/4 times 20k and -1/4 times 80. So when I do that, I get -5k plus 70 equals -5k minus 20. So I use the distributive property to do this. Now I'm going to look at the coefficients. I have -5 and -5 in front of the k. They are the same. So that should trigger something in your head that it's either no solution or infinite solution. Now I'm going to look at the constants. They are different. So I had the same coefficient, different constant. which means there's no solution. So just from this point, I can almost stop solving. I know right away there's no solution, so it would be pointless for me to go on. Third example. So I'm going to distribute on the left. I get negative 9x minus 45, and then bring down the rest. Next, I'm going to combine like terms on the right. So I noticed there was a negative x and negative 8x. Remember, if there's no number in front of the variable, it is a 1. So we have negative 1x minus 8x. Well, negative 1 minus 8 is negative 9. Now I'm left with negative 9x minus 45 equals negative 9x minus 45. I'm looking at the coefficients. They are the same. The constants are also the same. It's the exact same thing on both sides. Those are our infinite solutions. Okay, same on both sides, infinite solutions. In this lesson, we learned about the distributive property. And there are different ways that we can use the distributive property, and there might be different meanings behind it, but essentially what's happening is the number outside gets multiplied to everything inside. They all get that exact same treatment. Okay? Every part of the group is multiplied. It can also represent situations where the same process is applied multiple times. So, at a restaurant, you buy a combo meal. You get a burger, fries, and a drink. Your friend buys the same combo meal, burger, fries, and a drink. In total, you each got a burger. There were 2. You each got fries. There were 2. You each got a drink. There were 2. So we could have used the distributive property to figure out how many of each item, saying 2 times our combo meal, burger, fries, and drinks. When we're solving equations, there are also 3 types of solutions that can show up. So first, if you can solve the equation, it has one solution. This is the usual situation that you're used to where you end up with an answer. And we learned that that shows up when you have different coefficients on each side. Our other options are where the equation can't be solved because the variables would completely cancel each other out. It's the same on both sides. And you end up with 2 options. Okay, you end up with no solution. If you were to keep going and solve, it's never going to be true. Your variables would cancel out. You're left with your constants, such as 4 equals 9. It's not going to work. Or your infinite solutions. These are the things that are always true. So the left side and the right side are always going to be true because they are the exact same thing. After this lesson, do you now know how to solve equations using our distributive property? And can you determine how many solutions an equation has? By looking at the coefficients and the constants, using that structure. If you're not sure on these things, go back and look at some examples, especially focusing on how the distributive property is used and how we can tell how many solutions an equation has. And that is our end of lesson 6.